So here we're going to be going over the steps on how to perform a two-proportion confidence interval. And the key here to remember is that anytime I'm looking at two samples, I'm really preoccupied with what's the difference between them. So to go ahead and get started here, every confidence interval always has the first step being list. And because I'm going to have two different samples, I'm going to make two different lists for it. I'll list sample 1 and I'll list sample 2. When I go to list sample 1 here, because I'm dealing with proportions, I need to list p hat and I need to list n. Now, here's the difference. Because I have two samples, I'm not just going to call it p hat, I'm actually going to call it p1 hat and n1. I'll do the same thing for sample 2, p2 hat and n2. Now because I'm comparing my samples, I'm also going to go ahead and take the difference. Keep in mind, if they're equal, this would be 0. So that's really what I'm keeping in mind. Okay, so I've got P1 hat, P2 hat, N1, N2, the difference, and the final thing I need, because I'm running a confidence interval, is my z-score. Remember, for a 95% confidence interval, I'll have z equals 1.96. Okay, step 2 of this is always my calculations. The only calculation I have to make when I'm doing confidence intervals is to go ahead and find SE. Now, I want you to think back to what the formula was for a one proportion confidence interval. And that formula was square root p hat 1 minus p hat all over n. Now, it turns out that in order to go ahead and get SE for a two sample one, we basically do this a second time. So, I'm going to go ahead and change this to p1 hat, p1 hat, n1, and I'm going to add, extending that square root out, p2 hat 1 minus p2 hat all over n2. So my formula gets a lot longer. Now, a key note here is that if you're going to go ahead and calculate this by plugging it in manually, make sure that you do this, add them, and then square root. That is if you want to do it one step at a time. If you plug in all at once, you're going to be totally fine with it. So once again, the important thing is if you're doing it one little step at a time, make sure you square root it as the very last step. Step 3, as always, is to go ahead and put together our interval. Our interval is focused on the difference, so the first thing I write down is the difference between my samples. Remember that this is called a point estimate. It's the actual difference we found in our samples. I take that and I add and subtract z times SE, and remember this is what we call our margin of error. And that's because we're saying, okay, our samples are probably not lining up exactly with the population. So if I add in the fact that there's probably some error in the calculation, what are the possibilities I'd get out of here? We'll talk through how to state your answer once we go through our first example. Notice once again, I've got all 3 steps, just like every confidence interval I've ever done. And with any time I'm doing 2 samples, I'm always asking about the difference between them. Now, quick note, it does not matter which one we choose to be sample 1 or sample 2. I'm always going to be choosing sample 1 to be the bigger proportion so that when I subtract them, I get a positive number. But really, it doesn't matter.